Hey, it's Mrs. Moret, and I'm going to go over the review for your Unit 6 mid-unit assessment. So the first section, switching between angle measure and rotation, or angle measure and radians, and then how much of a rotation of the entire circle. So knowing that the full circle is 2 pi radians, that's the value that we use to go back and forth. So if we're going to go, easier to go, I think, to think about going from the rotation to the angle measure. So I'm going to take that 1/8 and multiply it by 2 pi. So 1/8 times 2 is 0.25, which is 1/4. Remember, math, enter, enter helps you get things back into fractions. And so 1/4 pi is the angle measure here, or pi over 4, either one. Now, so I multiply to go from rotation to angle measure. I'll just write it here. To go in this direction, I multiply by 2 pi. So to go in the other direction, I divide by 2 pi or multiply by 1 over 2 pi. Okay, so those are the same thing. So multiply to go this way by 2 pi, multiply by its reciprocal, 1 over 2 pi, to go in the other direction. So for pi over 6, I'm going to take that pi over 6 in radians and multiply it by 1 over 2 pi. And see, the pi's will cancel each other out, and I have 1, and 6 times 2 is 12. So an angle measure of pi over 6 is 1/12 of a full rotation. All right, I'm not going to do this entire table, just to make sure you know the strategy. Multiply by 2 pi to go from the rotation of the circle to the angle measure. Multiply by 1 over 2 pi to go from the angle measure to the rotation of the circle. So maybe one more of each. I'll do this one down here. It's 7/8. So to go up to the angle measure, I'm going to take 7/8, and I just do 7 divided by 8 on my calculator, multiply it by 2. It gives me a decimal. Math, enter, enter, changes that decimal to a fraction, 7/4. So a rotation of 7/8 is at an angle of 7/4 of pi. And one more to go from radians to rotation. So I'll do 2 pi over 3. So 2 pi over 3 times this 1 over 2 pi to go in that direction. And actually this time the 2 pi's cancel each other out, both the 2 and the pi. And so I just have 1/3. And so 2 pi over 3 is 1/3 rotation of the full circle. All right. In the next section, we have a wheel with a radius of 1 foot. The radius is 1. And so name 2 counterclockwise direction angles so that point P returns to its original spot. So counterclockwise, I'm going to go in this direction. And in order for it to get back there, a full rotation is 2 pi. But it says I need 2 of these, so we can just take another lap from here, another lap around, gives us 4 pi. And then for each of the angles stated above, state the distance in feet the wheel has traveled. So for one rotation, that's like 1 circumference of the wheel. And for 2 rotations, that's 2 circumference of the wheel. So since circumference is equal to 2 pi times the radius, and the radius is 1, it ends up being 2 pi times 1. So for a rotation of 2 pi radians, the wheel actually also travels a distance of 2 pi because the radius is 1, so we're multiplying by 1. And then for 2 full rotations, same idea. the wheel actually travels a distance of 4 pi. And I should have written feet because this is a horizontal distance. I'm going to write that at the end. Okay, and then next is a clockwise angle that will land on point P. So a clockwise angle that will land on point P. Now we're going to go in this direction. It's still like a 2 pi angle altogether, but it's in the negative direction. So negative 2 pi. All right. Okay, next. A rotation takes P to Q. P to Q. What could the measure of the angle of rotation be in radians? Okay, so two positive angles. So I know from here to here, well, this is 0 and this is pi. And so that first angle could just be half of pi. And then to have two positive angles, I could start, do this and then continue with another lap. And so I just have to add 2 pi. That's what a full lap is. Or I can think of it as this is 1/2, 2/2, 3/2, 4/2, 5/2 of pi. So 1/2 of pi, 5/2 of pi. And we could keep going so that we could keep going in multiple laps, adding 2 pi every time, but we only need to have 2. So then 2 negative angles going in the other direction. I'm going to change colors. Going in the other direction, that goes through 3/2 of pi, 1, 2, 3, in the negative direction. So negative 3/2 pi. And then one full lap from there, we're going to be adding 2 pi. So this is negative 3/2, negative 4/2, negative 5/2, negative 6/2. Finally, negative 7/2 of pi. All right, I'm just going to do one of these down here in number 4. The Pythagorean identity to solve each problem. Remember, the Pythagorean identity comes from the Pythagorean theorem, knowing that if you have a point on the circle, we know that the distance for x is the cosine of the angle, the distance for y is the sine of the angle, and we also know these make legs of a right triangle with a hypotenuse of 1. And so the Pythagorean identity tells us that the cosine squared of an angle plus the sine squared of an angle is equal to 1. All comes from the Pythagorean theorem. So if I know the cosine is at negative 0.9, that means that this point down here has an x value of negative 0.9, and then we have to find the y value. Now, when I find the y value, I'm going to get a positive answer, but I just have to remember y is negative down here. So I know one thing, and that's that the sine of theta is a negative value. So let's go ahead and find what that number is. Let's switch back to blue. It's easier to see. Okay, so I set this up just like I would a squared plus b squared equals c squared. So negative 0.9. If I forget parentheses around that, it's going to tell me that that's a negative number when I square it, but it's not. Plus, I'm going to use y squared just because it's easier to write instead of sine squared, is equal to 1. So I just have to do a little work on my calculator. Okay, so negative 0.9 squared is 0.81. So I know this is 0.81, so I'm going to take it away from the 1 to get y squared by itself. Minus 0.81 gives me 0.19, okay? So this was 0.81. I took it away from 1, and I'm at the point where I know y squared is equal to 0.19. That tells me that y is the square root of 0.19. And again, I know it's negative because, can you go out because I'm making a video? Just make sure it closes all the way. It's okay. I know that y is negative down here, so the sign value is negative square root of 0.19. Now, you can put that in your calculator, but this is the exact answer, so I'm going to keep it like that. All right. And the last question on the front side, we'll go over that really quickly. So first, plot each of these angles. So these are all angles that are on your unit circle. You should be able to plot those just by looking at your unit circle and knowing, matching them up. So pi over 3 is right up here. So this is pi over 3. Pi over 2 is right here at the very top. Pi is over here on the side. And then 5/6 pi is right before it. And 7/4 of pi. 7/4 of pi is halfway through this quadrant. Again, those are all on your unit circle. So make sure you have a complete unit circle before you come to take this test. Now, name the negative angle of rotation which takes P to the same point, the same locations for each of the previously stated points. All right, so for pi over 3, this one here, all you have to do is go directly below it, look at your unit circle, and that is where I see 5/3 pi, so negative 5/3 of pi will also land at that same point. For pi over 2, right under it is 3 pi over 2, so negative 3 pi over 2, or 3/2 of pi, will land at that same point. For pi, negative pi, just same distance, opposite direction. 5/6 of pi is here, and right below it is 7/6 of pi. Again, I'm just looking at the unit circle. 5/6 of pi is here, right below it is 7/6 of pi, so negative 7/6 of pi will land up there. Negative 7/6 of pi. And then for 7 pi over 4, it's right here. Right above it is 1/4 pi. So 1/4 pi in the positive direction lands here, but in the negative direction lands here. So negative 1/4 pi. All right, come back for side 2.